Hi, I'm Ms. Kinner, and I'm back to talk about finishing up the water project. So, next we'll talk about cohesive and adhesive forces. Hi, my name is Ms. Kinner, and I'm back to finish talking about how to finish up the water project. Next, we'll talk about high specific heat and salting the roads. So, high specific heat is one of those new properties of water that you could discuss for that item on the rubric. Water has a really high specific heat, and specific heat is just the amount of heat needed to raise 1 gram of water 1 degree C. And water's is really higher than a lot of other liquids of similar size and things because of its strong hydrogen bonds. So, just like it takes a lot of energy to evaporate water because of those strong hydrogen bonds, it takes a lot of energy to just change water's temperature. And so, this has a huge influence on global climates because all of our oceans really help moderate global temperature. All of the water on Earth really helps moderate temperature. And we even notice this in our local climates. For example, when we have a lot of moisture content in the air in Minnesota and a lot of lakes, and that makes our overall temperatures moderate. And what I mean by that is that temperature doesn't fluctuate much, for example, from day to night. Whereas if you've ever been out in the desert, if you go camping in the desert, in the daytime, you might be super hot when the sun's shining and be wearing a tank top and shorts. And then by the time that go to sleep at night in your tent, you might need your winter sleeping bag, a winter coat, and a hat and mittens. And when you wake up in the morning, you might cook breakfast in your hat and mittens and winter coat. And I know this from camping in the desert. It's great, place to go on spring break is to go to Arizona or Utah and go backpacking. But you need a whole variety of gear because you're super hot in the daytime when all that sun's beating down on you, and it's super cold at night. And the key reason or key difference from camping other places is that when you're out in the desert, there's not much water vapor in the air. And so there's not that water to moderate the temperature. Whereas, for example, in Minnesota, once it gets hot here in the summertime, we have a lot of water vapor in the air to moderate the temperature. And so it doesn't cool off as much at night. And we notice this in pools and lakes too. The first hot day of summer, our lakes and pools haven't warmed up yet. In fact, it takes a long time into the summer before our lakes and pools start to warm up because it's going to take a lot of heat energy to raise water's temperature. And that's because to raise its temperature, you have to start to break some of those hydrogen bonds. And they're really strong. That's a really strong intermolecular force. So, water's high specific heat capacity really moderates local climates. It moderates our global climate. It's the reason that lakes and rivers and pools are very slow to heat up and also slow to cool down and freeze in the winter. And the last topic I wanted to talk about was why we salt the roads, right? Why do we salt icy roads? Because we know solubility is a requirement on the rubric. And so I thought I might mention this. We know that what solutes do, so a solute would be like salt or sugar. What adding a solute to the solution can do is make it harder for those hexagons to form for water. They inhibit or get in the way of crystal formation. And in the case of water, it's forming those hexagons. And so, what that does is lower or depress water's freezing point so that water can't freeze until it's even colder. And so that means that, what we have done when we put salt on the roads in the winter is made sure that that ice shouldn't form until it's an even colder temperature. We're trying to depress the freezing point a little bit of the ice on the roads so that it won't freeze at exactly 0 degrees C, that it's maybe -8 or -10 degrees Celsius before that ice formation will occur. So we're trying to interfere with the formation of hydrogen bonds that are needed to make ice. And we can see it over here on the right. If we have salt molecules, what they're doing is getting those salt ions are getting in the way of hydrogen bonds forming, and they're taking the place of some of those water molecules in their hexagons. And then they can't form their nice, neat hexagons, making it harder for water to freeze and making that freezing occur at a lower temperature. So hopefully that helps you to wrap up your water project.